So today's lecture is about safety devices. What are the safety devices we use? We have several types of safety devices: fuses, circuit breakers, the relays, overload relay, under voltage relay, under frequency relays. So many protecting devices, safety devices we have. So under that, today's lecture we are going to see what is fuse. Fuse, ADS, automatic disconnection from the supply. So what do you mean by that? And what are the types of fuses are available? In HRC, high rupturing capacity fuses. What is the law of fuse? And how to find out the fuse rating for different electrical equipments like motor, transformers, single phase motor, three phase motor for electronic devices. So how to design the fuse rating? And what are the characteristics of fuses? Features. What features we have to see when we design a fuse? And what are the advantages and disadvantages of fuses? So these are the topics to be seen. And the first point about the fuse is an electrical safety sacrificial device. It operates to provide overcurrent protection for electrical circuit, either in source or load circuit. So the fuse will be connected near to the source side or to the load side. So this is a sacrificial device. So that will melt itself whenever there is an overloaded. Under overloaded condition or a short circuit condition, the fuse will melt and it will protect the device. So when too much current flows, the fuse wire melts, interrupts the current and opens the circuit. That is called as a fuse. And fuse operates due to short circuit current, overloading, mismatching, load, and device failure. So what do you mean by this overloading, mismatching? So actually, suppose we have a circuit like this. So here a fuse is connected. Here you have some fuse of 5 amperes of fuse is connected here. So this is one line, phase line or neutral. This is one line. So here you have one fuse and this is connected to a load. Load can be any type of load. So I'm marking it to be the load to be marked as a 4 amperes of load. So this is actual rating, current rating of a load. So whenever there is a 4 amperes current, there will not be any problem. The current will flow to the load, from the source to the load. If there is any abnormality, suppose I'm overloading it. So what do you mean by overloading? I just defining what is mean by overloading. Suppose I'm overloading it. I'm connecting one more device here. And that device range of the current is 2 ampere. So now it has become 6 amperes. Whenever it is getting overloaded, then this 5 amperes fuse will blow. It is overloaded. And it will protect the electrical equipments here. It will open the circuit and it will protect the device here. So fuse is very much required to protect the high costlier electrical equipment, as well as to avoid any leakage of current, as well as it will not give hazards to the human beings also. So this is one form of overloading. And what do you mean by short circuit current? Short circuit current is, suppose if there is any short in the line is getting connected here, then this is called shorted. So there will be more amount of current flowing through the circuit. That would be more than this 5 amperes of current. So this is the fault which is called as the short circuit fault. In that case also the fuse will blow. Overloading, short circuit, mismatching of the load, device failure, any failure in the device also. Suppose your device is having 2 pins and the pin is getting broken. That time also leakage current may occur, short circuit current may occur. So that is the reasons behind why a fuse is connected and how to protect the electrical equipment. So next point is fuse is normally made up of elements like zinc, silver, aluminum, copper, and it will be alloys of tin and lead, all metals like. We have different elements that is used for different ratings. We have different current ratings and we have different characteristics, like we need what is the time response according to the time response, how fast the fuse has to blow and how much time it has to withstand, what is the time response, what is the delay time, and what is the current rating. So according to that, the fuse is rated. Now this is about short notes about the fuse. And to the next point. So next slide. Next slide, this is of different types of fuses. We have 1,000 types of fuses. So as we said, specification varies for different current ratings and for different applications, AC and DC. And for a different time delay purpose, time response purpose, we go for different types of fuses. There are many types of fuses. So this is example I have shown, like cartridge type of fuses. So which is having a glass and that is sealed with the metal cap. So this is used for low voltage and high voltage and short circuit currents to protect against low voltage, high voltage and short circuit current. Cartridge type of fuses. This is the diagram which is showing after the fuse is getting cut, the fuse wire getting melt. So this just cutout type of fuse. And here this type of fuse we use in our home. So residential purpose we use such fuses. So this type of fuses. So this is the fuse and this fuse holder is there. Here we can put that wiring. So fuse with a fuse holder. This one type of residential type of fuses are there. We have NH type of fuses that will be in a square shape. NH type of fuses, that is HRC fuses, high rupture capacity fuses. Under high rupture capacity fuses, we have NH type, we have D in, and many types of the rewirable fuses or their miniature fuses, semiconductor fuses. We have lot of thousands of varieties of fuses are available. Only thing, because of its specification, what is the time response, how fast the semiconductor fuses are ultra fast. It is very fast. It is very fast in operation. So because of different specification, we go for different types of fuses. So moving to next slide. Calculation of fuse ratings for motors, electronic devices, and transformers. So how to calculate the fuse rate? So if you want to design a fuse, for an equipment, how to calculate? Normally what mistake we do is we don't ask for the professionals, for a technical person to design a fuse. We ourselves change the fuse. That rewirable type of fuses, we ourselves change the fuse without proper knowledge of that. So that will be a great disadvantages of fuse. So we must know how to design the fuse, what should be the exact fuse rating, and we must learn from the professionals and experienced people how to change the fuse. So here the first point is single phase motor fuse rating. So if it is a single phase induction motor, what should be the fuse rating? It should be 1.25 times the full load current. So here, what do you mean by full load current? 1.2 times the full load current. So what do you mean by full load current? We know the formula, power is equal to V into I. Power is equal to V into I, or VI is equal to power. Then I is equal to P by V. This is your full load current. So I is equal to P by V. So what is the electrical equipment power rated in kilowatts, and what is the voltage? If it is a single phase, it is going to be 230 voltage. And what will be its power factor also? That can be also added. What is the PF value? So this is the way how we find out what is the full load current. That current into 1.25 times will give you the fuse rating of a single phase motor. Next one is called three phase motor. So for the three phase motor, the fuse rating is 1.25 times the full load current. Again, for three phase, how to find out the formula for I? I is actually for three phase, this is the formula. Power is equal to root 3. Instead of root 3, here I have mentioned as 1.732. Root 3 VI cos pi. This is the actual power formula for three phase motor. So from this power is equal to root 3 VI cos pi, we have to find out what is I. I will be your full load current. I is your full load current. So I is equal to power divided by root 3 V cos pi. Cos pi is your power factor. Any inductive motor or any transformer, everything will have power factor. That will be a lagging power factor. So that is 0.7 power factor. So instead of cos pi, for example, I have shown here one problem. So in that it is given 0.7 power factor. So what will be your fuse rating when you calculate for a three-phase motor is 1.25 times of the full load current. Find out from this formula what is the I value, and that I value into 1.25 times will give you what is the fuse rating to be designed. And when you go for very high starting current machines, very high starting three-phase induction motors, squirrel gauge induction motors, all having high starting current. So these cases you can use 1.5 times. Instead of 1.25, you can go for 1.5 times the fuse rating of your full load current. So for electronic transformers and smaller motors under three-phase, you can go for 1.1 times of the fuse rating. So this is an example I have shown with the calculation. Numerical value is given. So calculate the fuse for 5.5 kilowatts. So kilowatts is nothing but it is a power. And V is equal to 415 voltage. And it is a three-phase induction motor, runs at 0.7 power factor. Very simple calculation. So what we must do, power is equal to 1.732 is root 3 VI cos pi. In this voltage, we will substitute 415. Then power, we will substitute 5.5 kilowatts. From this, we have to find out what is the I value. And with the I value, what I am getting is 10.93 into 1.25 times. That will be your fuse current. It is approximately 13.66. So we can select the fuse range of 16 amperes. So fuse is having certain types of ranges, 1 amps, 2 amps, 3 amps, and 16 amps, 32 amps. So near about that value, we can take the value of that fuse for a short circuit and overloaded condition. But if you need for the exact value of the fuse, the manufacturer can design for that also. If you quote and give for the manufacturer will design for that also. So this is how we find out the fuse rating for a motors, fuse rating for a three-phase motor, for a transformers, for a small motors and these things. So I have shown with one example. You can try this and solve it and find out what would be the exact fuse rating. So the next slide. So this slide is for your transformers. So what will be the fuse rating of a transformer, three-phase transformer? So for transformer, we don't rate it in kW, we rate it in kVA, because the losses we represent in voltage and current only, voltage and amperes, VA. We don't rate it in kW. Okay, so we always rate it in kVA. So that is called as an apparent power. So apparent power divided by the voltage, that into 2 times will give you the fuse rating of the particular transformer. Then how to find out the fuse rating for the light panel circuit? Many panel circuits will be there. Suppose 10 lights will be connected. So 10 into the individual power. So that you will get what is the current rating of that. So after the current rating is calculated into 2 times, that will be your fuse rating. So it is called full load current. Full load current into that 2 times will give you the fuse rating of your light panel. Then we have these are the standard fuse sizes. We have 1, 2, 3, 4, 6, 10, 16, 32, 40, 63, 125, 150, 160. And if you want to design anything for 1100, I want a fuse, 1100 ampere, manufacturer will do according to that. So these are about how to calculate the fuse ratings. So we have find out how to calculate the fuse rating by using the full load current value. The full load current value is calculated by the formula power divided by voltage. Okay, moving to the next slide. The next slide is about the characteristics of the fuse. So what are the characteristics of the fuse? I square T fuse. So this is called as the heating capacity. Heat is equal to I square RT. We have the formula I square RT for the heat. So that is also called as melting current. So when the current increases, the melting time of the element decreases because your I and T is inversely proportional. So when your current increases, your melting time element will get decreased. So this is also called as the melting current. I square T is also called as melting current. This is to find out what is the heat. So heat is equal to I square RT. That is the actual thing. So this both is inversely proportional. How we can say it as an inversely proportional is actually, I can use the pen. Is this a pen? Okay, so suppose if it is, oh, it is a vanishing pen. Suppose if this is the characteristics is having time graph and current graph, time and current. So this graph will show like this. Meaning is when your time is at 0 point, this reaches here. If you take the time in 0 point, the current is at maximum point at 0. When your time is at maximum point, your time reaches here at maximum point, your current comes to the minimum point. Here it is the actual reading. So this both is inversely proportional. That's why it is given that when the current increases, the melting time of the element decreases. So this is also called as the melting current. Heat capacity, H is equal to I square RT. So that is the actual formula. From that formula, we can say which is directly proportional and which is inversely proportional also. The next one is called as the fuse materials. This is primary characteristic of general characteristics of a fuse. High resistivity. The fuse material is having very high resistivity and low melting point. So that is called as the general characteristics, high resistivity and low melting point. It melts down due to overcurrent flow. And that is a formula for that. And next is current voltage ratings. Current and voltage rating of the fuse is a normal rated current and rated voltage. That will withstand, the fuse can withstand without getting melting. So that is the normal rated voltage and current that can withstand without melting. So next is temperature. The fuse melts when temperature increases and the current rating is lower. So that is the temperature. So the fuse melts when temperature increases and the current rating is lower. So that is the specification and characteristics of the fuse. We go for the next. The fuse rating, how to find out the fuse rating. The current at which the fuse element melt, its value will be more than the rated current. Obviously, the current where the fuse element is going to melt will be always more than your rated current. So the relation between your fuse current and the diameter of the wire. So the fuse current is equal to K into diameter to the power of 3 by 2. So this is the fuse current, how to find out the fuse current and what is the relationship between your diameter of the wire. And K is the constant of a fuse. This K constant will vary from each element, whether it can be zinc or it can be silver or aluminum, tin or alloys of some other elements. So like fuse elements. So this diameter and current relation. So the K is a constant of each element. And what is the fusing factor? The fusing factor is the ratio of fusing current to rated current. The ratio of fusing current to the rated current. So what do you mean by fusing current? Fusing current is the the current of fuse rating, what we found out, and that divided by the rated current is a rated full load current. Normally, the fusing factor will be more than 1. It has to be more than 1. And for some, it may reach up to 2 or more than that. So that is the ratio of the fusing current. It should be more than 1. And what is the breaking capacity? Interrupting rating. Breaking capacity must be at least equal to prospective short circuit current. Higher the breaking capacity is more capable of protecting against high intensity short circuit current. So that is, your breaking capacity must be at least equal to the prospective short circuit current. So breaking current is an interrupting current. So that is capable of protecting against sudden high short circuit current. It has to interrupt and break. And these are the advantages and disadvantages of fuses. Advantages, we can say it is inexpensive, it's readily available, easily replaceable, and requires no maintenance. It does not require any maintenance. It's very cheap. So that is inexpensive. Then it can break without any noise or smoke or any big flame. So it is very easy to handle without any maintenance. It can be automatic and fast operation. Inverse time current characteristics of fuse makes it suitable for overcurrent protection. And it is very smaller size, not a bigger size or very large in weight. So it is very compact and very small in size. And what is a disadvantage? Disadvantage, when fuse blown, then fuse has to be replaced with a new one, which can be a real inconvenience. That may take some time, and we have to know what is the proper rating and what the manufacturer. We cannot go for different manufacturer. It has to be a proper type. We have different type, 1,000 types of fuses are there. So if once it is blown, replacing it or rewiring it, that will take some inconvenience. That is a disadvantage. Fuses are bought by ourselves and installed without professional advice can lead to not fulfilling their protection purpose, may not be fulfilled. So that may be a problem that lead to fulfilling their protection purpose. Difficult to identify once blown. It is difficult to discriminate the fuse when fuse connected in series. So we have these are the disadvantages of the fuse. And we have HRC type of fuses, high rupture capacity type of fuses. So this type of fuse is mostly used. So these fuses have different types also. We have DIN type, we have NH type. NH type is used for low and high voltage protection. So these type of fuses, or it is made up of a ceramic material, and inside we have some powders to quench the arc. So no flame or arcing will come out. The arc will get quenched by itself inside. And we have two metal caps by out. By the two ends, we have two metal caps. This type of HRC fuses, high rupture capacity fuses, are mostly used for industrial purpose. And thank you for listening.